Hello class, and welcome to Notes 4.5, Simplifying Square Roots. Our vocabulary today is simplest form of a radical expression when the expression under the radical sign has no perfect square factors other than 1, and no radicals appear in the denominator of a fraction. And I'll explain that a little more when we get to that example. Our rule today is the product property of square roots, and I thought it'd be easiest to show that using an example instead of words. So radical A, B, notice both of them are under the radical sign, is the same thing as saying radical A times radical B. Because remember, when two variables are right next to each other, it means multiplication. So for example, if I have radical 24, I can break that down and say, well, 6 times 4 is 24. So if I split them up, I can break down the 4. Now notice, 4 is a perfect square, so I can break it down into a 2 and leaving the 6 alone. 8 times 3 also makes 24, but neither of those are perfect squares, so that doesn't help you at all. So you want to really be looking for those perfect squares, and I'll tell you a little more about that in a bit. Quotient of square roots, same thing. Radical A over B is the same thing as radical A over radical B. For example, radical 7 over 25 is the same thing as saying radical 7 over radical 25. And of course, the radical 25 can be broken down to become just 5, because the square root of 25 is 5, and the 7 will be left alone. Okay, so let me explain this a little further. Teacher example 1. Write the radical expression in simplest form. So what I'm looking for is a perfect square that can go into 125. Now, I want to break this into two numbers, and one thing you want to be careful of, perfect squares, remember, are not just integers. They're numbers that can be square rooted to become an integer. So, my examples of perfect squares again are 1, 4, 9, 16, 25, 36, 49, 64, and so on. So remember, two integers multiplied together to make a perfect square. So if I take a look there, I know that 5 can go into 125, but it's not a perfect square. So I need to look through my list, and I recommend you write your list at the top, starting with 1, and it'll make it a lot easier. So hopefully you noticed that 25 times 5 makes 125. So I can break it down into two separate ones. And you can either write it as one giant radical sign, or you can write it as two little radical signs. That doesn't matter. So, notice I've broken it now into two little radical signs. The square root of 25 is obviously 5, and 5 has no square roots, and there are no perfect squares within it, so I leave it alone. And I have the 5 from the 25 is outside. Notice, once I've square rooted a number, I've used up the radical sign. And then this 5 that's under the radical sign, there's nothing I can do with it, so I leave it underneath. Okay? So I want you to go ahead and try this out. First of all, you want to turn this into two numbers that are multiplied together. One of them needs to be a perfect square on each of those. You can square root the perfect square, leave the remaining number underneath the radical sign. Okay, go ahead and try it out. Okay, let's take a look and see how you did. Radical 8, the things that can make 8 obviously are 2 and 4. 4 being a perfect square tells you that that will work. So I've got radical 4 times radical 2. And 4, of course, is made up of 2 squared. So now, notice I can cross out the radical and the 2 and turn that just into the number 2. This 2 that's underneath the radical, I haven't used it. So I can't get rid of it unless I've used it. So I leave it as 2 radical 2. Radical 27 is made up of 9 times 3. 9 being the perfect square, I can square root that and make it 3 squared. Notice I can't do anything with the radical 3, so I just keep bringing it down. And now the radical and the 2, I can cross cancel those out, and I end up with 3 radical 3. Next problem, problem number 3, we have radical 75. Again, I'm looking for a perfect square that can go into it. And I have 25 times 3. So I can turn 25 into 5 squared. The radical 3, again, I have to leave it alone because there's nothing I can do. So I have radical 5 squared. The radical and the square cancel out. and end with 5 radical 3. Hopefully you got all those right. If not, make sure you take a minute to correct them. Moving on to teacher example 2, simplifying the radical expression. So now I've got the opposite. Before, I had a number that was combined that I had to split up. Now I have a number that's split up that I need to combine. So what I want to do is 3 times 15, and I end up with 45. And now I can break 45 down into a new number that one of those needs to be a perfect square. So notice 3 and 15 do make 45, but neither of those was a perfect square. So I need to break it down differently. And hopefully you noticed that radical 9 times 5 makes 45 as well. The reason why this was a better way to break it down is because 9 is a perfect square. So I can split up the 9 and the 5. 9, of course, is 3 squared. So I can cancel out the square and the radical and end up with 3. And I just bring the radical 5 straight down. So go ahead and try this on your own now. Remember, multiply the numbers together, keeping them underneath the radical sign, and see if you can split them up in a different way that gives you radicals for your answers. Okay, go ahead and try it out. Okay, let's take a look and see how you did. We've got 2 times 6 makes 12. And then obviously I know 2 and 6 I could break it back down to 2 and 6, but neither of those is a perfect square. So I'm going to break it down to 4 and 3. 4, of course, means 2 squared. And I can cross cancel the 2 and the radical, the square and the radical, to leave you with just 2. And the radical 3 stays the same. Okay, 3 times 6 means 18. And to break it down, I can break it down between 9 times 2. 9 being the perfect square, which would be the same thing as saying 3 squared. So remember, 9 is the same as 3 squared. They mean exactly the same thing. But the reason why I want to break it down this way is now I can cancel out the radical and the square and end up with 3 rad 2, or 3 radical 2. 8 times 12 is 96. And this might have been a little bit tricky for you to figure out a perfect square that goes in 96. So what you want to try are skip counting by perfect squares. You will notice that 4 works, but you'll still have a perfect square inside there, which works, you just need to break it down again. You will also notice that 16 works. And notice 6 doesn't have any perfect squares in it, so you've gone as far as you can. So you can break down 16 by making it 4 squared, cross cancel the radical and the square, and end up with 4 radical 6. So keep in mind there, that was kind of a tricky one. If you had multiplied by 4, you would have ended up with 4 times 24, and then you would have had to break down that 24 as to 4 times 6. And you'd end up with 2 times 2 times radical 6. And 2 times 2, of course, is 4. We don't know what radical 6 is, so we have to leave it alone. Okay, so hopefully you ended up with that answer with whichever method you chose. And let's take a look at a teacher example 3. Simplify the radical expression. Notice we're back to, again, those giant radical signs. The first thing I want to do is take that giant radical sign into 2 little ones, one for each of those. So radical 11 over radical 49. Now, radical 11, there's nothing I can do with it. It's not a perfect square. I have to leave it alone. Radical 49, however, is a perfect square, and I turn it into 7. I now have simplified the radical expression because I no longer have a radical in my denominator. And there's nothing left to do in the numerator. So go ahead and try these out. Make 2 small radical signs and then square root. Remember, you have to square root the denominator. You can square root the numerator if possible. Okay, welcome back. Let's take a look. Radical 3 over radical 4. And of course, the square root of 4 is 2. Here we'd have radical 2 over radical 9. And of course, the square root of 9 is 3. Here we have radical 5 over radical 16. And of course, the square root of 16 is 4. Okay, nice and easy. So just make sure you're taking care of that denominator. So go into quiz 4.5, simplify the expression. All of these are what you just did. Radical 99, you want to make sure you pull out any perfect squares that you can. Your answer may still have a radical in it. Number 2, you want to multiply together and then pull out your perfect squares. And number 3, you want to break it down into 2 radicals. Have a great day.